因为我们今天那个讲者的内容蛮丰富的，所以我们这段就不要特别去休息，我们中间休息个10分钟。那如果要上厕所的朋友们就直接出去没关系。然后因为你们可能会发觉说，他们在讲英文方面，那可能有一些伙伴们可能听不太清楚。那我们在最后的 Q&A 就是5点，最后一位讲者，4点多这位讲者讲完之后，我们会请所有的讲者我们会坐在前面，然后所以让台下的朋友发问这样子，然后可以试着说，因为我们为什么办这个活动哦？放玻璃属于原料商哦，台湾有很多，比如说我们本身司马，我们在做防水涂料、地坪材料，还有粘着剂，还有瓷砖，我们本业有在生产瓷砖哦，是那个红州窑业。那如果在涂料这块哦，我们跟原料厂买原料进来之后，我们在做销售的时候，有时候名称我们会做变化。第一个是要让我们第一线的施工客户听得懂。第二种是要稍微变一下。如果同一种原料进到3个品牌商里面，交到施工客户的时候，你们会接收到3种不同资讯，但是它是同一种东西。所以我们在办研讨会的时候，就是希望施工者在第一线可以慢慢的去了解原料最原始的化学结构跟材料特性。这样子，因为你以后面对比较聪明的客户，还是说一些比较尖端的客户，现在资讯很透明，很多东西你如果没有跟他讲得很清楚，还是说讲得正确，他们上网去查之后，会对所有的材料商会有疑问，也会造成施工商方面会价格有时候拉不高，价格拉高也要展现一些专业性，但专业性需要时间去累积，所以第一场如果英文方面可能听不太懂没关系，我们到最后 Q&A 的时候会做一次补充，那有问题的时候到那时候可以一起发问这样子。那我们进行第2个阶段哦。
What I forgot to mention before, the presentation itself at the beginning was a little more extensive, so we had to shorten a bit. But you will find some more information in the handout you have got and on the homepage of Lion Horse. So if you want, you can have a deeper look into some specific parts concerning structures and so on. And if there are questions, please don't hesitate to contact Van Berlin Singapore, Van Berlin Taiwan, or myself at HQ in Switzerland. So, as a matter of fact, the first I was asked for was to hold a presentation about possibilities of silicates in the treatment of concrete. So, what I made of it is a large part about concrete treatment and some glances on other applications in the field of construction and construction materials. So what I want to go through with you is the silicates in concrete floor finishing, some words on concrete acceleration, some words on silicates as binders in silicate paints and plasters, and a few words on soil grouting and injection of silicates. Once more, the nice glass pieces, and how do we use those in concrete floor finishing, and why do we do that? First of all, silicates always are a green alternative. As we learned in the presentation before, we have a chemical that is very close related to natural occurring silicates, and it will become something almost indistinguishable to all those silicates we find in nature. It is inorganic, non-toxic, not allergenic, free of any volatile organic compounds. The application is easy and quick, It's an impregnation. That's very necessary information. We have an impregnation, not a coating. We will come to that later on. It is strengthening the surface. It is binding loose particles in your surface, and it can be quite cost efficient. So we need about 0.2 to 0.4 liters per square meter.
好的，我们现在谈到硒酸盐用在混凝土的地坪当中。可溶性硒酸盐它是绿色产品，为什么呢？因为它是无机的、无毒、无过敏性，不含 VOC， 应用简单快捷，沉浸不是涂层，加强表面，结合松散的颗粒，它有着成本效益，它只是需要 0.2 到 0.4 千克在1平方米里面。
Furthermore, to show that we are really dealing with a green chemical in brackets, so we've got a green certificate. We could get the Indoor Advantage Gold certificate by SCS Global Services, so from the US, and we can use it indoors whenever necessary. So that's the good point of using a lot of money to get some tests.
好的，我们的所有的水泥基固化剂有着绿色证书，所以是环保型的，无毒无害处的。
Trying to tell you what the different silicates are doing in concrete flooring. So mostly we have to look first at what is the state of the concrete. Is it a fresh concrete? Is it an old existing one? It is a porous one? It is a very dense one? So this more or less tells us how to proceed. So what we can say, just from the size of the ions, lithium will penetrate easier than sodium and easier than potassium. But they do penetrate and they do react. That's what is strengthening the surface. It will reduce diameters of the pores you have in the system. So it will help water not to penetrate, and when water cannot penetrate, it will not bring dirt with it. So also the cleaning of the floor will be easier. The surfaces treated can be grinded and also polished. So to this strengthening, I always say strengthening, not hardening. So it's strengthening, and this will help you polishing and grinding.
好的，根据待处理混凝土的质量，可以使用不同的硒酸盐，但我们仍然建议主要使用锂或甚至硒酸钾来减少分化。其中我们建议硒酸锂，因为它的渗透性会来得比硒酸钠跟硒酸钾来得好。硒酸盐确实渗透并反应，因此它们强化了表面，孔径减少，所以水和污垢的渗透也减少。用硒酸盐的处理，可以使表面容易的研磨，并可以抛光，以达到很亮丽的表面，有着镜子般的亮面。
As I mentioned before, what do we have? A film-forming substance or not? So what is film forming? If you, for example, apply an epoxy coating on a concrete floor, it will look like this. In the REM picture, you can see dense closed surface. What we do looks more like that. So there will be a fine layer of glass in the pores, also on top, but it's not really a coating like we see here. And if we look at it in the REM, we still see very rough, very porous, open for water vapor to pass. That's more or less why you can start with impregnating the concrete also when it is fresh. So if you have to apply an epoxy coating, you have to wait till the concrete has fully cured, let's say 4 weeks, 5 weeks. Here, if the concrete has got enough strength to step on, you can start with the work.
好的，涂膜形成与否，成膜、涂层，例如环氧树脂；非成膜、浸剂，就好比我们的硒酸盐。硒酸盐有着水蒸气渗透自如的功效，它有着呼吸功能， 所以它并非是一个涂膜，它有着渗透的功能，它可以硬化你的体系。
So how do you work? The first, as mentioned, you don't need to wait till the concrete has fully set. You can start smoothing the surface as soon as it has got enough strength to support, to be stepped on and to be work with machines. In the second go, you impregnate the first time with the silicate. In the third go, you start grinding and then polishing. Probably it makes sense to change the product in the middle, to respray some silicate just to be sure that the top surface has got enough silicate and is strengthened enough.
好的，如何做这份工作呢？其实无需等待混凝土完全凝固，使表面平滑，喷涂或喷溅细酸盐，研磨抛光，在步骤之间喷洒新鲜的细酸盐，2个小时后就可以随意踩在地坪上。
So how long does it last? That's our warehouse in Taichung. Thank you, David, for the pictures. That's it. When it was freshly treated about 2 years ago, and that's it today, after 2 years of use. Yes, there are some marks from the forklift, but in total, after 2 years intense use, it's still a very nice floor.
好的，混凝土细酸盐有着效果非常持久的一个功效。可以看到我左边的一个图片，那就是我们用这细酸盐用在我们的台湾厂范伯利台湾有限公司的仓库和其他等等的地方。在我的右手边是2年之后的使用，可是你还可以从照片当中你可以看到细酸盐巩固了我们的地坪，它还是一样的耐，一样的持久。
So summarizing the advantages, it's an easy to do reaction and an easy to do work, and it does not lead to a coating. So chipping is not possible. Cracks, yes, cracks can always occur. In this case, only when the concrete itself cracks. So a cracking of the impregnation is not possible because there is no layer on that could crack. The concrete itself is strengthened by a chemical reaction. You don't need any post-treatment except removing surplus of silicate, and you will reduce the pore size and thus make it more or less impenetrable for liquid water, and thus also the transportation of dirt into the surface or into the pores is not possible. So chipping and things like that we don't want to see. What we want is this.
好的，我们谈到细酸盐的好处。其实用细酸盐是不会导致涂层的效果，因此它不可能发生去裂，只能在混凝土结构当中发生裂缝。混凝土经过化学反应，加强地面，巩固地面，没有后期治疗的必要。还可以减小洞口的尺寸，因此水和污染物不容易渗透进基材，可以养制水和污染物的进入。
Just one thing besides, you see that shininess. That's not the silicate. That's not the glass. That's the concrete. So what we do with the silicate is strengthen the concrete surface in a way that itself can be polished. So that's not a shiny silicate layer that makes that glossy aspect. That's the concrete itself. What have we done to test? One of the first tests I have done was using the Schmidt hammer to check on the compressive strength of some concrete samples we have in our headquarters. I have no idea when the building really has been built, but it must have been somewhere in the 1950s. So the first part I tested was a very old and concrete floor. and brittle concrete floor with an original compressive strength of 60 Newton per square millimeter, so quite weak. I treated it with 602 first, so the lithium potassium, and it went up to 24. And I retreated it with 612, the lithium, and it went up to 26. So I could improve the class of the concrete after our European classification from 1620 to 2530. I'm pretty sure 2530 is, depending on what you want to do, a value that could be used for further treatment or for to coat it with something else. 1620 surely is not. On the other hand, the still good concrete floor, just close to the other one, with an original strength of 40, I could bring it up to 44, just by the same treatment. So an improvement within its class.
好的，通过用热水泥基固化剂，我们能提高抗压强度。我们就用了 Smith-Hammer 的反弹测试。其中测试在总部古老而聚落的混凝土地坪，我们可以看到它原始的抗压强度是16，但透过用我们的细酸锂钾的治疗，它提升到24，然后我们再用我们的细酸锂重新处理，我们就能达到26。所以这证明了它从 C16 或20级改为 C25 甚至30级。另外一个测试是总部旧但依然很好的混凝土地坪，一开始它的抗压强度是40，通过使用细酸锂钾的治疗，我们能达到42，然后我们再用细酸锂重新治疗、重新处理，我们能达到44。所以这里我们可以看到，它有这C40或50级内的改进。
The next test we did was trying to figure out how the penetration of water and of chemicals is reduced. What we did is we put the two blocks. The one on the left side is treated with Inacot 602, so the lithium potassium, and the right one is not treated at all. So what happens is, as you can see, the water droplet as well as the diluted hydrochloric acid droplet, they remain on top of this very porous block. On the other hand, if in the untreated, immediately it is sucked into the substance.
好的，细酸盐有着防水性的功能。通过细酸锂钾的渗入，我们可以减少液体的渗入。然后图片当中我们可以看到不同液体的行为在处理和未处理混凝土的块状表面。在我的右手边，你可以看得到没有经过处理的地坪，它很容易渗透；而在我的左手边，透过细酸锂钾的渗透，它有着防水的功能。
Another test we did with the same kind of blocks, very porous ones. We have treated some fully with Inacot 602 or with Inacot 612. We dried them for 4 days at 40 degrees, then adjusted to room temperature, and then put it on the water, so underwater for 20 minutes. After the treatment, we put them out, let them dry at the surface, and took the weight to determine how much water has been absorbed. So that's just where they lay underwater, and that's the outcome. So the porous concrete, let's say water cement ratio about 0.7, and the standard concrete 0.5, 0.45. So we have in the untreated block 3.6% of water taken up. After the treatment, it goes down on 2.5 or 2.6. The good concrete, not absorbing much water, just 1% itself, but after the treatment, it's even lower, 0.4, 0.6. So also this shows us that the pores of the concrete are really smaller than they have been before.
好的，透过细酸盐的使用，我们可以减少吸水量。首先，我们的混凝土块用细酸锂钾或纯细酸锂来完全处理。 我们在40度以下干燥4天，然后我们在室温下调节至环境温度2小时，在水中保持20分钟，然后将混凝土块放在室温下保持25分钟，然后称重。在这个实验当中，我们可以看得到，经过处理的水泥基地面，减少了水的渗透。在没有处理的地面，水的渗透是很多的。
The next slide I should not show, in fact. It was a concrete block sealed on 5 sides with some plastic material and treated on the 6th side with the Unicode 602 or 612. Also dried for 4 days, adjusted to room temperature, and then placed in water under 5 bars of pressure for 3 days to check how water under pressure penetrates into the concrete. That's how it looked like afterwards. And the outcome was very funny. The porous concrete did not change a lot with 602, but it changed with 612. So the penetration depth even became higher. The standard concrete on the other side, 42 millimeters versus 22 or 23. Here you can see an improvement. So how can I explain that a very good water cement ratio concrete improves and a more lower quality concrete, the improvement is not there. On the other hand, it's worse. That's more or less what I tried to show with those slides. So what do? We do coat the pores on the inside. So if I put a very fine layer of silicate, some micro or nanometers onto some 10 micrometer pore, it will not be affected, it will be smoothened a little. If I do it with a very good concrete with very small pores, it will almost be closed. So that's why small pores react with a better value. Here, the smoothened, not much affected pores react with an easier penetration. But never forget the penetration we have been talking about was at 5 bars pressure and for 3 days.
好的，我们现在谈到压力下的水渗透。混凝土块封闭在横向两侧，并使用细酸锂钾或纯细酸铝来处理。在40度摄氏下干燥4天，在室温下2小时后，将水泥基块状放在5帕压力下暴露于水中3天，然后分切块并测量穿过深度。这里我们可以看到它的测试数据，令人不可思议。透过细酸锂钾的处理，在多孔混凝土当中，它的数据是106，反而在纯细酸锂的处理之后，它的数据是122，反而更高，而没有处理的只有100。这是因为它的颗粒、它的渗透的关系。因为多孔混凝土它有着很多的孔，所以很容易就被细酸锂钾填满，所以水的渗透被阻止。而细酸锂、纯锂，因为它的颗粒比较小，所以它用的量会需要很多，所以它不能填满所有的洞口，所以在压力下，水的渗透会导致很多。OK， 在这里我们可以看到，用水和石灰的对比，在0.6到0.8的混凝土当中进行内孔涂层，平均孔径多大于10微米。而用水和石灰的对比，0.4到0.5的混凝土当中进行内孔涂层，平均孔径小于10微米。细酸盐处理渗透到固化混凝土中的影响很大程度取决于混凝土的等级。在低质量的高水泥比混凝土，例如0.7当中，有着没有或者甚至不能测量的影响。 较高等级的混凝土，例如另一方面，它的水和水泥的对比是0.5，显示水的渗透深度减少了30到50%。
The next thing we tried to figure out was acid resistance. We are talking about the glass. Glass, in fact, is quite resistant against acids of all kinds except hydrofluoric acid. So what we did is we sealed another block or a few other blocks on 5 sites. We treated the 6th site with Inacot 612 for 602. Also dried it and acclimated it, and then it was put into water containing acetic acid at pH 4 for 30 days. pH was adjusted daily. After this treatment, so you will not see much after the treatment, except that there are some bubbles in the plastic around. But what we wanted to see is, after this treatment, how does the water take up change? And that's what came out. The porous concrete, we did not test it on the good concrete because there is almost no penetration. So if you really want to see an effect, you need a porous concrete, what we did. And look at that. It went up from 3.6 to 4.1 in the untreated. It remained almost the same on 2.5 for the Inacot 602. And we had a slight increase from 2.6 to 3.3 with the lithium. So if you have a porous concrete, if you need a resistance against acid, lithium potassium is better than the pure lithium.
好，我们这里谈到耐酸性。同样的，我们将混凝土块封密在横向两侧，干后我们使用细酸钾锂或者是细酸锂来处理。在室温下2小时后，将块置于含有异酸，碱酸度4的狱中30天。我们每天调值它的碱酸度。处理后，我们测定它的吸水力。通过细酸盐渗入混凝土表面，导致孔内部的玻璃细状涂层，内表面的这级玻璃化表现出抗酸金属稳定性的增加。或处理的地面有着比较少的水的吸水量，跟没有处理过的地面来相比。
So what products do we have? In fact, we have 3 different product rows, just the densifying, the silicate binder, the Inacot 601, 611, which are the concentrates, the 602 and 612, which are in most cases ready to use. We have some having some hydrophobic effects, which are equipped additional with water repellents, where we know they still show a good hydrophobicity after 1 year of outside weathering. And we have some with oleophobic effects, which we can only use indoors, because outdoor weathering after 1 year, the oleophobic effect is almost gone. But normally, if I need oleophobic effect, that is parking garage and things like that, so that's no outside weathering.
好的，我们的混凝土水泥固化剂有着保护混凝土的功能，其中它有致密，还有细酸盐粘合剂的功能。为了有疏水作用，我们加上防水添加剂，然后疏油的效果，我们加上疏油添加剂。然后这个疏油产品只能用在室内，而不是用在室外。
And that's the portfolio as it exists at the moment. As mentioned before, 601, 611, the concentrated products, modifiable for outdoor use, can be used outdoors. Inacot 612 down to 619O, including the hydrophobic and oleophobic H&O types, ready-to-use products. Outdoor use, yes, except the oleophobic. What do? Very good hydrophobicity, good hydrophobicity, good oleophobicity, very good oleophobicity. Always the penetration of the pure lithium is a little better than the one of the potassium lithium. On the other hand, the gloss and the strengthening of the surface always is slightly better with the lithium potassium than with the pure lithium. Depending on our customers, it can make sense to use the concentrate, to buy the concentrate, to mix yourself whatever you need. Or if you're the end user, it could make sense to have those ready-to-use products.
好的，这边我们可以看到产品的介绍。这边有着8种产品，其中601跟611是高固含量的产品，你们必须稀释后才能使用，不然的话就会有反白的效果。601是我们的锂钾硒酸盐，它是高固含量，然后你必须稀释了才能使用。而我们的611是硒酸锂纯锂的产品，这个也是高固含，所以你们必须稀释之后才能使用。602到619O 是现用型，不需要掺任何的水，你们直接喷洒在混凝土地面上。602是锂钾的硒酸盐，612是纯锂的硒酸盐，608H 是锂钾硒酸盐，有着疏水功能，然后618H 是纯锂的硒酸盐，有着疏水功能，然后609O 是锂钾硒酸盐，有着防油防水的效果。619O 是纯锂的硒酸盐，有着疏油疏水的效果。然后如果看着你的地面、你的基材是什么性能，然后来选择我们的产品。基本上比较疏松、比较不密集的地坪，我们建议使用锂钾的产品，而不是纯锂的产品。
Leaving the technology of surface treatment, just giving you a quick glance on concrete acceleration. So the guys working with cement and concrete amongst you, they will know this equation. That's how the concrete people display the curing reaction of concrete. For me, or for the chemists amongst you, that's more or less how we see it. So the calcium silicate plus water gives the calcium silicate hydrate plus calcium hydroxide. The normal curing reaction of cement-based systems. What we can see from the above reaction is the consume of water and the formation of calcium hydroxide. As we learned in the first presentation, consuming water from silicates make them combine, force them to react, rise viscosity, and calcium hydroxide as a very good soluble calcium compound, the calcium ion will additionally force the silicate to react. So what happens if I react calcium hydroxide with silicate? I will form a kind of calcium silicate hydrate, so the same as comes out from the normal curing reaction. All those things together, when the silicates are present, the remove of water will force the silicate molecules to combine. The silicate molecules will react the Ca2+, forming calcium silicate hydrate, and thus not only form additional hydrate, but also consume one of the products of this reaction, so force the reaction to go in this direction. And you will notice very fast, if you just add a few percent of, let's say, sodium silicate into the water you use for your concrete, it will cure much faster than without.
OK， 好的，这里我们看到水泥的硬化，透过硒酸钾、硒酸钙水合物的反应。从上面的反应我们可以看出，水被消耗并形成氢氧化钙。当存在碱性硒酸盐时，水的去除将破及硒酸盐分子结合，同时硒酸盐分子将与 钙离子反应形成细酸钙水合物。因此，水的消耗以及水泥形成的氢氧化钙破击细酸盐反应并硬化，细酸盐去除氢氧化钙，又增加了氢氧化钙水合物反应的反应速度。
As next point, I would like to give you some insight on silicate paints. By the way, if you ever come to Venice in Europe, that's close to Venice, the island of Murano with all those picturesque houses. They say it was for the fishermen, when they come home drunk at night, they can look just which color their house has and they will have no problem to find their home. Nevertheless, what is a paint? A paint always needs some solvent. In case of silicates, when silicates are present, the solvent must be water. No other solvent will work.
OK， 我们谈到油漆粘合剂，在无机涂料中，我们有着水，在细酸盐的存在，溶剂肯定是水，它不容易溶剂。
The second we need is a binder. In case of standard silicate paints as they are produced today, we always have a binder system consisting of potassium silicate and acrylic or styrene acrylic resin.
好的，在涂料当中，我们也需要粘合剂。这粘合剂里面包括细酸钾、丙烯酸或苯乙烯丙基酸的树脂。
The next we need is fillers. We have to give some stability to our coating, otherwise we will not have a coating like we have seen before. So what fillers can we use? We have alkaline conditions and we have silicate present, so everything that can react with the silicate cannot be used. Calcium carbonate, mica, talcum, quartz, fluorocalcinide, no problem. If you have, for example, a very soluble magnesium carbonate, it will not work.
好的，填料在涂料当中也是扮演很重要的角色。细酸盐本身有着很高的碱性，所以填料的筛选是很重要的。碳酸钙、云母、滑石粉、化尔脂粉、高磷石，它们的纯度是很重要的。
The next, pigments. Whether it is white or whether it is colored, we need some pigments. Iron oxide, spinel pigments, titanium dioxide or heavy spar are suitable. Most of the organic pigments you can use in other paints are not suitable for silicate paints because they cannot stand the high pH value.
在涂料当中，颜料是很重要的，因为我们都需要颜色。所有的无机涂料、无机色粉都是跟细酸盐相融的。
We need some additives. Antifoam, dispersing aids, thickening agents, hydrophobic agents, to have at the end a paint that does its job at the wall, looking nicely and protecting the substrate.
添加剂也在涂料中扮演着很重要的角色。我们这边有需要加到消泡剂、分散剂等等的助剂。
And last but not least, for silicate paint, we need stabilizers. The stabilizer does nothing else than prohibiting or hindering the reaction of the silicate. So, if this is not present, the paint will be able to use for, let's say, half a year. If you need storage stability of 2 years or even 1 year, you need some stabilizer to slow down the silicate reaction, because all the reactions here are very slow, but they happen. And the reaction that happen here are exactly the same as we want to happen when the paint is applied to the wall. So if you have too much stabilizer, yes, it's stable for the next 50 years, but the reaction to the wall that we need to get a good coating will not be there anymore.
好的，在无机涂料当中，稳定剂也是很需要的。我们需要来稳定剂来稳定我们的涂料，然后我们的涂料完成的涂料我们可以储存，不然的话，因为它是细酸盐的涂料，所以它的反应是很快的。如果没有添加稳定剂的话，你的涂料是不能储存的，它会很容易固化凝结。
I think we're a little short of time, so I will skip that, chemical grouting and wall injection, or go through very quick. In fact, what you can do with silicate with a hardener is inject it in the ground to form a gel, and this gel will help you to bring your ground or your building ground into a state that you can go over with heavy machinery. So chemical grouting, instead of cement, you can also use silicates together with a hardener, forming gels, and these gels, depending on how they are prepared, will be washed out in the next couple of years or will remain for the next couple of 100 years. Wall injection, one of the problems we sometimes have, especially with older buildings, is water penetrating through the wall along cracks into the basement. In bad situations, even into the living area. So what you can do is impregnate the pores and the cracks into the wall by hydrophobic agents together with silicate, making it gel inside those cracks, and the gel picks up water, swells, and closes the pores and the cracks for water to penetrate. So drying out the basement can be done with such technologies. So, as a summary, the same as before, inorganic, ecological, growth relatives to 90% of the Earth's crust, waterborne, not containing any solvent, and thus absolutely VOC-free. Most suitable for the use with almost all mineral fillers, and always useful to be used on absorptive material surfaces. So it's not really possible to use silicates on a very dense surface, like for example polished marble or polished granite. So it needs some penetration depth to properly work. The systems like paint or plaster, they do not form dense films. It's the same as on the floor. We don't have a closed surface film like with an epoxy coating. We still have a porous system open for water vapor to pass, and thus a moisture exchange through the wall and through the coating is possible. Without fillers, as we learned, there is no film formation. If there is a film formation, you will have a lot of shrinkage, you will have cracks in that film, and the film will come off quite easily. So whenever you have problems on the floor with white spots and cracks, that means too much silicate used to impregnate. And the most interesting thing, silicates do not only stick to the surface, they react with all silica containing particles, with all silica containing substrates, and they bind the stuff chemically to the surface. Treated with or painted surfaces, they show a very high service life. So we have pictures or houses in Switzerland painted with the old, that we have to say, the old two-component, purely inorganic silicate paint, somewhere in the late 1800s, 1886, still having the same coating, still looking quite good. And also here, compared to other binders, silicates are quite cost-effective, and they have a long-term protecting function on the substrate. As a rule of thumb, about 30 years a conventional silicate paint will do its job.
好的，很快的，我们来到摘要。可溶性矽酸盐是无机的、生态的，相近于98%的地壳。矽酸盐的溶液是水，不含任何溶剂，因此不含 VOC。矽酸盐的溶液最适合与矿物填料和吸收性矿物表面一起使用。油漆和石膏等矽酸盐系统不会形成致密的薄膜，但水蒸气开放和多孔涂层，可通过成品系统进行水分交换，所谓的呼吸自如。 没有填料的矽酸盐溶液不会在基材上形成薄膜，而只在毛孔，它们起着沉浸的作用。可溶性矽酸盐不仅粘附在含有颗粒和表面的二氧化硒或矽酸盐上，而且与这些颗粒和表面反应。用于可溶性矽酸盐的产品涂料或处理的表面具有高使用寿命。矽酸盐体系具有高成本效益，并且在基材上具有长期保护的功能，因为它们有着渗透的功能，可以巩固你的基材。
Then once more, thank you very much for your attention. Thank you once more that I could come here for this presentation. And last but not least, thank you to you, Bijin, for the translation. Wonderful. Thanks a lot, and I'm pleased to answer your question at the end of the seminar later in the evening. Thank you.
好，谢谢来宾，谢谢你们的时间。Thank you guys for your interest.